in color, damaging plastics. They are easily and potentially irreversibly absorbed by some materials. And in the case of natural science specimens, some pesticides can rapidly change cellular material, which renders the specimens useless for DNA studies.
So today we are going to talk about kind of the 4 prolonged approaches to implementing IPM, and that is Cherry already mentioned some of these, but they are avoiding and blocking pests from establishing a home in your collection in the first place, detecting an infestation and assessing the extent of the situation, identifying exactly what the pests in your collections are and where they are, and responding in a way which is sensitive to the needs of the collection's staff and the environment. So Cherry will start us off with how to do that first method we talked about, avoiding and blocking.
Okay, so the first step we want to talk about in integrated pest management is blocking. Because if they can't get in to begin with, then you're not going to have such a big problem with them. So I kind of liken the museum environment to a set of nesting dolls, these cute little guys you see on the screen. First, you start with your building envelope as the primary defense. So you pay attention to the foundations, the walls, the roof, windows, and doors. The insects can get into tiny, tiny spaces, and rats can come in through an opening the size of a quarter, mice through a space the size of a dime. Then, inside your building, you have your collections room or even your exhibit hall. So that's the next layer. Then inside these rooms are your cabinets or shelves. And then finally, in the cabinets, or on the shelves, you may have individual boxes or other containers. So there are lots of levels where you can protect and block, and you really want to pay attention to each of these. And it's a great thing that you have so many levels for blocking. So what attracts pests? Removing the things that attract pests is another important line of defense. So pests are drawn to your collections for four big things attract them: food, warmth, humidity, and hiding spots. And these hiding spots include flowers and plants, gaps in the floor, ventilation ducts, dark places, old boxes, and even piles of paper. I know that sometimes things kind of get ahead. We kind of get behind on going through our collections, and so piles of papers and boxes can kind of pile up. So those are actually good hiding spaces. And also I want to add stacks of firewood. So if you are in a historic site or historic house with a fireplace, that may be something you want to remember to keep an eye on too. In terms of humidity, if you can keep your humidity down to at least 50, but 45% may be better, you're going to eliminate a lot of problems, the dampness that a lot of insects are attracted to, particularly, so say book lice. These actually live off of mold and mildew, and they retain water in their bodies. So if you can eliminate that damp, keep your humidity down to 50 or even 45%, then these are going to just dry up and die, and you won't really have a problem with them at all. Okay, so preventive methods to avoid and block insect pests. Housekeeping. So regular routine housekeeping is potentially one of the most important things you can do to avoid a pest infestation, because you're removing food sources for the pest, and regular cleaning also allows you to monitor some of the dark and hidden areas in your collections for nests. Having time to regularly and thoroughly inspect your collection for early signs of an infestation is crucial to stopping a problem in its tracks. You want to seal gaps in building envelopes and repair holes and cracks This is going to block the pests from coming in, and it sounds simple, but it is very highly effective. Also, segregating potentially infested objects from other collections materials as they come in is crucial, so you want to quarantine things. This can be done using a procedure known as isolation, which we're going to talk about in a little bit. Really being mindful about the things that enter your collection can save you from a lot of difficulty and heartache later on. I personally like to quarantine everything for a couple of weeks before it goes into the permanent collection room, and I know that not everyone has space for that, but if you can assign a space, that's something you want to consider. And you want to do this whether it's a brand new object to your collection or if it's something that's been out on loan.
Great. Thank you. So I'm going to now pick it up and talk a little bit about assessment of your pest situation, much in the way that you would prepare for potential security risks or natural disasters, as we did in our last in-person workshop, how we did a risk assessment of the site. You also want to do a similar sort of assessment to help evaluate your institution for potential pest risks as well. So this means doing a thorough inspection, conducting a monitoring program, and getting to know the creatures that inhabit your institution. The first series of questions that you want to be able to answer before there's a problem are kind of listed up on this slide. Which part of your collections are most at risk? Is it the herbarium specimens or a collection of rare books or perhaps both? What part of the building or buildings are most at risk? If there's, outdoor components or places that aren't as well sealed. Are there activities in your institution that you carry out that might increase the risk, such as serving food or drink during events? That might present a good opportunity for pests to have some other food to eat. And are there signs of insects or other pests that you or your colleagues have noticed in the past? If you do believe that you have an infestation, the next step is to evaluate how serious the situation is. Where have pests been noted in your collections? What stage in the life cycle are they? If you found larvae, that indicates that they're probably breeding, for example. Is there any visible damage? Are you finding carcasses, or are they still alive? How many are there? What type of species are they? And the really scary question, how many objects have been affected? I apologize, this slide got a little messed up when we transferred it into the webinar format, but the information is still there. We will discuss the materials that attract pests when we discuss identification, but just in general, pests sort of tend to be drawn to protein matter, such as hair, leather, or vegetable matter, or starch. Unfortunately, that just about covers everything in a collection, more or less. They particularly like objects if they're damp or dirty, because that provides even extra food and extra hydration. If you're in a historic house, your largest artifact, the house itself, could also be at risk. Think about termites, how much they love wood. So consider what materials are at risk out there. Monitoring insect populations with traps is simple and effective for pinpointing exactly what and where an infestation is occurring. Sticky traps, or blunder traps as they're also known, are probably the most common type of trap used to monitor insects. These traps are designed to trap in the crawling insects. They're small enough to be placed in those kind of dark corners underneath furniture, hide them all around your rooms, and they will stick. Things that crawl over them will stick. They will also trap things like lizards and mice, so you need to be careful of that. We'll discuss humane traps in a minute, but it's good to know. I learned from experience the hard way that you can break down adhesives and freeze those types of pests if you want to, using mineral oils, not mineral spirits, mineral oils. So kind of a good thing I learned the hard way if you do get some of those other creatures trapped in your sticky traps. Pheromone traps are also really helpful. They can be used to trap flying insects such as moths or crawling insects such as roaches. When you do use these, it is important to know what pests you're trying to trap, as pheromones differ for different types of pests. Male insects are drawn by the hormone given off by female insects to, attract a mate. Um, so you have to know what you're kind of aiming for. You need to kind of have a good understanding of what you have happening in your institution, and the way you'll figure out what you have and what you should be trapping for is by using those sticky traps first to figure out, and then figuring out who you need to be luring away to other areas. Once insects enter the traps, the insects can't get out. It cuts down on the breeding, and excuse me, it kind of helps to track their movements around the institution. So traps should be placed in a regular pattern around the building, with their positions marked on a map of the building or area of the building that you're trying to track. Traps should be inspected regularly, with the number and type of insects recorded. This will help you determine whether the insects you're catching are actually pests, and it will help you determine their life cycle. If you notice larvae in the trap, that indicates that the insects are breeding, for example. For non-insect pests, the same procedure applies, although you would want to check them more frequently, because if left too long, it's possible that an animal carcass might attract more pests and just kind of be grosser in general. As I mentioned, you can use the humane traps. You don't have to necessarily kill them. These ones, for example, are available for mice. You do have to check them and empty them regularly, though, and make sure that you're taking them to a place very, very far away from your institution, or else they might come right back in. This greenhouse trap is a humane trap called the Smart Mouse Trap, and they're available online at most hardware stores, so you can find those. But in conclusion, traps are necessary to identify and track pests and non-pests, pinpoint an increase in insect population in a specific area, monitor the spread of pests from one area to another, track an invasion of adult insects in the summer, pinpoint a localized infestation in a problem area, and determine the success or failure of a control treatment that you might try to implement. So they're very useful. Once you've trapped them, then you'll have to ID them, and I'm going to pass it back over to Cherry for more information on that.
Okay, thank you. So I know looking at this, you may think, how can I ever figure out what kind of pests these are? But actually, even though that can seem kind of overwhelming, especially to the unaided eye, there are a lot of resources out there for you to use. So don't worry too much about it being too tricky. We're going to begin by looking at how you can identify the various insects and also some vertebrates which might be in your collections, because knowing what to look for can help you really kind of nip the problem in the bud. Okay, so here is a map of your area. Actually, we really have a lot of the same pests all over the United States, although the species can vary. And these typically include book lice, cigarette beetles, carpet beetles, cockroaches, termites, case-bearing clothes moths, silverfish, and fire brats. And there are, of course, many others, but these are some of the most reliable offenders. And when we talk about those lovely hiding places for things, I really want to call attention to, well, let's see, where did it go? Here we go. Here she is. This little guy right here, the brown recluse spider. These are very common across North America, but we see them an awful lot here in Alabama. They love to hide in cardboard boxes, as do black widows. And contrary to common mythology, they will not kill you instantly if you were bitten by one. And they don't really hurt your collections, but they can hurt you. They can make you ill. death by brown recluse is not instant and is actually very extremely rare, but I want you to be aware that they do like to hide down in these boxes and things, and so just keep that in mind for your own safety. Know your pest. First of all, what is a pest? Well, for our purposes, a pest is any insect or other arthropod, rodents, birds, really any creatures who do not belong inside the buildings. And actually, we're going to talk a little bit more about that because some are actually helpful. But mostly, things that live outside don't need to be in your building. And pests really can include fungus and mold. Vertebrates can include rats, mice, rodents like rats, mice, and squirrels, or birds. And occasionally larger vertebrates such as rabbits, feral cats, bats, raccoons, possums, and snakes. So you're less likely to see the larger vertebrates in your collection, but they are more common than you might think, especially in historic houses. And then, of course, the insects, which we spend a lot of time talking about, and then other arthropods like spiders and scorpions. And then finally, fungus and mold indicate that you have a humidity problem. They can ruin your objects and also serve as a food source for some other pests. Okay. Signs of pest activity include droppings, tooth or gnaw marks, or areas where you can see that something's been eaten away. Other signs include nests made from shredded paper or cloth, paw prints, unusual noises that you might hear in the wall, some scrambling around, and also unusual odors. So another is insect frass or poop, which can stain your objects. And then birds will often leave nest, feathers, and unfortunately also urine and excrement. And I'd like to also add a note of caution here as well. So please take safety regulations if you have to clean up any of this. So you want to wear your gloves and your mask because the excrement is related to some pretty nasty diseases. Okay, Samantha.
Sorry, I had my mic turned off. Yeah, I'm going to be spending some time talking about sign of pest activity for some of our insects, and some are less obvious, although much more common. For the purpose of identifying insect pest activity, we're going to divide them into these three general categories: borers, shredders, and grazers. So I encourage you to use one of the online pest atlases to visually identify the damage that pests leave behind. There are so many insects out there, and they often look very similar to the human eye. There's a wealth of information online, which is constantly being updated. But let's get you started today with some information. Borers damage hardwood and softwoods, animal glued plywood, furniture, wicker, wood pulp paper, and books. As they like to bore into them, as the name would suggest. They often leave behind exit holes, tunnels, and frass. As Cherry mentioned, frass is the nice word for the excrement. They basically leave behind a bunch of garbage, right? Behind by the insect larvae. So if you see these holes and brush the inside gently, the powdery frass will come out, and that is a sure sign that the insect has been breeding in there. As already mentioned, the frass itself can also leave behind stains and damage the artifact, so it's no good in general. Borers include the common furniture beetle, the woodworm, which is actually the larval stage of the furniture beetle, and the powder post beetle. The powder post beetle prefers hardwoods such as oak, ash, hardwood, and hickory. They can be found in the envelope of your building as well as in wooden objects such as furniture. So they can be everywhere. Common furniture beetles and their larvae, also known as the woodworm, enjoy damp wood environments and areas with high relative humidity. As an aside, most of these insects are tiny, 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 really only a few millimeters long. So this is where it comes in handy to have some kind of type of magnification device. We'll talk about putting together DIY pest kits in a minute, but good to know that these guys look big here, but they're not actually this large. Our next group is the shredders. The shredders consume keratin. So that's the protein in hair, wool, parchment, feathers, skin, horn, nails, hooves. So I think you guys can get a sense of what that is. They are the enemies of many textile collections. So Ryan, these guys are probably your enemies, right? And they also can wreak havoc on natural history collections. They leave behind a big mess of cast off skins, silken tubes, and frass. So, no good. Here we have some examples of the shredders. They can include webbing clothes moths, case-bearing clothes moths, and the white-shouldered house moth. If you've ever noticed holes in your favorite sweater, you most likely have a webbing cloth moth infestation. It's one thing to have it in your personal collection, another to have it in your museum, but both are annoying. Sometimes these moths are confused with the grain-eating moths that you'll find in cupboards at home, but clothes moths have tiny hairs on their head. If you catch a clothes moth and look at him close under the magnifying glass, you'll see that they have these furry little heads. The larval stage is the most dangerous for collections. The baby moths will feed on the protein as they grow. By the time you see them fluttering around, you already have a problem. There's already some damage being done and they are ready to breed. So these ones are pretty tricky. White-shouldered house moths are actually omnivorous, so they're attracted to grain sources as well as the protein in wool, fur, etc. They are easy to identify by the white patches on their shoulders, if they had shoulders in that area. That's how you would identify them. More shredders, just for fun. Many species of beetles also fall into this category. Varied carpet beetles, which look a lot like a decorative carpet themselves, prefer natural history specimens, rugs, textiles, fur. If you have other insect specimens, these guys would be attracted to that, and furniture. Their larva is really fuzzy, and they look like tiny caterpillars, so that's you can check for them. The black carpet beetle enjoys both animal protein and plant-based materials, so it's an equal opportunity destroyer. The vodka beetle prefers protein-based materials such as wool, skin, and hair. They're also attracted to dried herbarium specimens and other plant matter. The drugstore beetle is also known as the bread or biscuit beetle, and it can be found in dried vegetable material as well as furniture, natural history collections, fur, leather, and books. Moving on to our next set of problems, the grazers. So these pests primarily feed on starch and protein, and they really thrive in those damp conditions. So actually a great deal of pests thrive in that high humidity, so keeping that relative humidity in your collection under control is really, really crucial to avoiding an infestation. Grazers damage objects by scratching and eroding them, as you can see in this image here, where a silverfish has really badly damaged a book, grazed right along the surface, ate it right off. Grazers include common household insects such as silverfish and cockroaches, as well as book lice and cigarette beetles. Cigarette beetles infest books, herbarium specimens, leather, silk, and natural history objects. They tend to become very active in subdued light and fly around and then kind of play dead when the lights are on, so they can be tricky. Book lice are actually not lice, but they have a similar appearance. They feed on fungi and mold. So if you see book lice present, that could indicate that you have a mold problem. At the very least, it indicates that the relative humidity is too high. Book lice are drawn to the starchy adhesives in wallpaper or books, so lowering the relative humidity in affected areas, as Cherry was mentioning earlier, is really helpful, but you want to be probably around 50% or lower. That will help prevent their development by eliminating potential moldy food sources. And I know some of you have probably heard this story already, but I do have a good story about finding a book lice infestation in a museum I used to work at. We lowered the humidity, and then I set up a bunch of sticky traps around the perimeter of the room to discover where the book lice were coming in. They were actually coming in from the bathroom next door, and there was a small crack in the wall. The book lice were coming over in some additional water that was coming over from the bathroom next door. So we were able to find that, then block it up, and really focus on controlling the humidity. We'll talk more about responses in a minute, but that's always my favorite book lice story about finding them and blocking them. The last one here is the silverfish. They're attracted, you guys are probably familiar with these guys, they're attracted to starchy adhesives as well as proteins. This means that they will eat book bindings, carpets, textiles, glue, hair, paper, photographic material, cotton, silk, linen, lots of different materials will be eaten by silverfish. So I mentioned earlier that a lot of these are microscopic, so it can be really hard to identify them. In that book lice example that I was telling you about, those guys you cannot see with the naked eye. The only reason that I noticed that they were infesting this room was because my sticky traps, the glue, I could see that the surface of the glue was disrupted, so I knew to go look at that closer under a microscope. So you do have to sort of be keenly aware to these sort of things, but you can also create, inexpensive kits to help identify pests. Some of the materials that I have here you can find almost anywhere, but you want to sort of gather those together so that you can work to make a kit to help you really figure out what it is you have when you are looking at your pests. You can get a really small USB microscope, magnifying glass, or a loupe to help you kind of look at these things close up. I also had this little handheld microscope that I used to carry around with me to investigate things closer, so you can find some of those to help out. You definitely want to make sure you have a pet atlas, online resources, something to help you identify what it is that you have. That, of course, doesn't have to walk around with you, but maybe be at your desk so you can try to figure out what it is that you have. The sticky traps and pheromones that we talked about. A light source can be really helpful. Something else that I've noticed is a lot of the bugs will scatter when the lights turn on. So even just realizing as soon as you turn the lights on to sort of be looking for movement can help indicate that something is around. Tweezers, of course, to help pick up and look at things. Small Ziploc baggies so you can kind of contain what you have. Small brush, pencil, pest log, etc. All will be helpful in your DIY pest ID kits. And I think something which is occasionally overlooked as we're going through all of these and discussing various insect pests is a reminder that not all insects that can be found in collections are necessarily bad, are necessarily pests. I was watching a webinar on pest management recently, and the instructor said that if you find absolutely no insects at all in your institution, it probably means that the environment is toxic and you probably don't want to be there. And, that kind of makes sense, right? So one insect that is particularly helpful for pest control is the pseudoscorpion or book scorpion. They're so small you probably would have overlooked them in your collection, but they're actually team players when it comes to pest management. That's because they eat some of the insects that you don't want in your collection, such as book lice, clothes moths, while leaving the books alone. So you can kind of think of them as unpaid interns who are very quiet and just helpful. Non-pest insects are important in that they can indicate another problem in your institution as well, such as building or environmental issues. Um, if you have a whole bunch of spiders in your collection or a whole bunch of book scorpions, you might have an infestation or an infiltration problem where bugs can get in really easily. So it can help you to kind of figure that out. But monitoring will help you to begin as well, some of the other methods that we talked about. Um, so I'm going to pass it over to Cherry now to talk a little bit about some of our response procedures.
Thank you, Samantha. So once you've been able to track your pest and identify where the problem is, where they're coming in, the next step you want to do is consider what are the options that you have for treating your collections. So here we have listed a number of options for you. There are a lot of different types of responses, but we're going to touch briefly on 4 of them, which are used by institutions to fight infestations. And these include isolation, low temperature treatment or freezing, heat treatment, modified atmosphere treatment, including anoxic, carbon dioxide, and nitrogen argon gas treatments. We're also going to talk briefly about 2 options that were common in the past, but we really don't recommend them now, and those, of course, are fumigation and pesticide treatment. It's helpful to know about all the options so that you can really make an informed choice that's best for your institution, and also particularly when working with professional pest control companies who may not really be familiar with the best treatments for archival and library objects or our 3-dimensional objects in your collections. And just a reminder too that no matter which of the treatments that you choose to use, always document in detail what you're using and how you go about it. Okay, so let's talk about isolation or bagging. So this is when an object that you suspect is infested, or a group of objects, is placed on a white backdrop, so a white blotter or another type of archivally safe material, and then it's sealed in a polyethylene bag. Then you want to monitor this bag for weeks or even months. This is especially good for objects that cannot, for whatever reason, be frozen or treated right away. So the pros of this type of treatment, isolation, is that it allows you to quarantine an object suspected of infestation so that nearby objects are not also infested. So it removes the infestation away from your other objects. It allows the object to be monitored for weeks or months so that pests can be identified and the life cycle stage determined, because we know that some pests are dangerous at certain life cycle stages, not at others, and the treatment of those stages may be different. Isolation can be used for a variety of types of objects. And another pro is that it's appropriate for complex objects and objects that are entering or re-entering your institution. But the cons for isolation and bagging is that it's very time consuming and it's only appropriate for a small number of objects. So let's look at the next treatment, which is low temperature or freezing an infested object in order to kill pests. Okay, sometimes this is used as a preventative measure when items arrive from a place that you think may have an infestation. You would first place the objects in a polyethylene bag, or if they're too large for a commercial bag that you can purchase, you may make your own with polyethylene sheets. Then you would put the objects in the place them in the freezer for a specified length of time, which is going to be at least 72 hours, and that's going to depend on the capacity of your freezer. When you put them in there, make sure that there's airflow around the objects, that they're not touching each other, and you also want to include an indoor-outdoor thermometer. So your goal here is to get the temperature down to at least -20 Celsius or -5 Fahrenheit. That's the minimum low temperature. Um, and so a lot of studies have been done on this, and talking with conservators and pest control specialists, what I'm hearing lately is that you actually can use or purchase a chest freezer, the kind that you would use in your home, so it doesn't have to be a very, very expensive commercial freezer. Um, and I've actually used this process in the past, but it's really important that if you go this route, you choose a freezer that does not have a frost-free cycle. You don't want the temperature, you don't want the frost-free cycle disrupting the consistency of your temperature. Um, again, when you're using a household freezer, the formula is 6 to 10 days at -20 Celsius. So if you can't get it down that low, leave it for longer. You may leave it for 2 weeks. And then another thing you want to consider is that you can do 2 cycles of freezing. So what you would do would be after the first initial cycle, take the objects out, allow them to return to room temperature, but keep them in their wrapping for about 24 hours, and then you can put them back in the freezer. And that is also the process you want to use for one cycle. So if you do one cycle, take the objects out, let them return to room temperature for 24 hours, and then you can actually, if you want to, put them in your collections room still in the bags. But then, of course, if you feel like you want to go ahead and do 2 cycles, you can do that too. And always, always document the process that you've used when you freeze an object. So the pros of low temperature treatment is that it's a short treatment time. Like I said, it can be 72 hours or at a lower temp or at a little bit higher temperature, a couple of weeks. And the cons are that you can't use this treatment on some finishes like oil or acrylic, paintings on canvas. You wouldn't want to use it for objects with layers of media, photographic materials, cased photographs, glass archival materials, some ceramics, metal, glass objects, or objects under tension like drums. And you don't want to use this process for ivory or for teeth. Another con is that it can increase the fragility of delicate objects, especially as you're returning them to the room temperature. Okay, Samantha, I'll let you take the heat treatment.
Yeah, so opposite of the freezing is, of course, the heat treatment. Exposure to heat can also be used to kill insects. Short exposures of 130 degrees Fahrenheit are sufficient to eradicate many pests, and this treatment can be scaled from using a chamber for a few objects to a large object on site or even an entire building, so it's pretty versatile. There are various versions of this heat treatment. 2 proprietary names for heat treatment are thermolignum and solar bagging, which uses the sun to reach the high temperatures needed to eradicate pests. The pros is this is very effective treatment, and as I mentioned before, it can be applied to both large and small scale infestations. You could even do an entire building if you needed. So as I said, very versatile in that way. The cons are that it's not recommended for items that are really sensitive to changes in RH. Temperature increases the ability of the air to hold humidity. So by heating something up, you can also cause a swing in RH. So you wouldn't want to use it on things that are going to be really sensitive to that. It's also not recommended, obviously, for things that will melt. So things with low melting points. That's like waxes, some adhesives, things that are flammable and explosive. There are often some plastics that might kind of get melted or deformed if you heat them up too much. So you do have to be really sort of conscious about the materials that are able to undergo this type of treatment. Next up, I wanted to talk about modified atmospheres. So that's, using the air around it to control the treatment. And this includes anoxia, controlled atmosphere treatment with carbon dioxide, and nitrogen argon gas treatments. So the anoxic treatment often uses oxygen scavenger packets, which pull the oxygen from the air. The infested object or objects are placed in a sealed enclosure with the packets, and the air is then removed. This is a similar process to silver bagging, if you guys have done that in the past. It takes the air out of the air. The oxygen levels are reduced to less than 0.5% for 3 weeks. Results in an atmosphere which is composed almost entirely of nitrogen, which will help to suffocate your little pest friends. The treatment length will vary, but approximately 21 days is sufficient to kill almost all the insects at all stages of life. The pros to this are it's pretty inexpensive, and it works on a variety of materials. It's proven to be very effective, so it can be a good option for you. Of course, there are always cons. It's a little bit time consuming to make the kind of enclosures that you need to have this for. Again, it can be difficult to maintain that RH equilibrium because you're messing with the surrounding environment. So again, you want to make sure that you're selecting objects that are pretty resistant to the changes in RH. It also has to be monitored. You can't just sort of set it and forget it. You have to make sure that you're checking on it. And there are some certain materials that don't work well with this, such as the Prussian blue dyes or pigments. Those are really sensitive to the nitrogen, so we can't use that. We can't have those in your anoxic treatments. And a cat, right? A cat is always good for controlling pests. In this case, a cat is meaning controlled atmospheric temperature. It's often inaccurately referred to as an anoxic treatment. However, a cat treatment uses carbon dioxide to displace oxygen in a sealed enclosure to low levels enough to kill insects, again, at all stages of life. After 3 to 4 weeks, the carbon dioxide is removed and the treatment is completed. So the pros for this one is that it is safe for most objects. You can also set it up in-house, which is always good. It's very effective at killing objects in sort of all those phases of its life, from the larval stage to the adult. And it doesn't really have the same sort of residual effects that some of the other treatments have. Of course, it is time-consuming, expensive. You do have to have some special equipment and knowledge. Certain regions, and you might need permits or licenses to use it. And again, it does have to be monitored at all times. The last treatment I wanted to talk about was the nitrogen argon gas treatment, which works similar to the other modified atmosphere treatments, using nitrogen and argon gas to push oxygen levels down to an inhospitable level for insects. Insects die usually between 2 to 6 weeks when using this method. The pros are that it can be more time efficient than the CO treatment. It's appropriate, again, for a wide variety of objects, and the argon can prevent biodegradation from fungi and bacteria. It's expensive, though, and nitrogen can also contribute to the growth of other certain microorganisms. So you have to know which materials you're selecting for this treatment. Then, of course, there are the non-recommended measures. We do want to talk about those for a minute. Fumigation was really a standard treatment in collections for a very long time, and unfortunately, some objects in museums, libraries, and archival collections still have residue from this procedure from many, many years ago. It isn't recommended except in cases where it is the last resort. If fumigation is chosen, you do want to remove objects from your collection and send it to a facility, as you really do not want to actually fumigate your collection materials. Chemicals which were considered safe in the past have left dangerous residues on some objects, including arsenic and mercury. I was at a library recently and I was looking at a couple of books that had gone through some of these treatments. They were painted with mercury or a mercury compound um, many, many years ago, and the residue from this treatment was still visible on the books. So this stuff can really kind of linger. And a final note about pesticides. We've talked a lot about, how to avoid them, but it's worth reiterating that you never want to treat collections materials directly with pesticides. This can change both the physical structure and the chemical makeup of an object, aside from leaving possible toxic residue. It's actually illegal in many areas for anyone who isn't certified commercially with an applicator to use large quantities of pesticides. So if you use any pesticides, you would need to be done through a licensed and registered vendor. Buildings can be treated in some cases, particularly in kind of the cracks and crevices of the building envelope. And this is actually quite common, but again, only by licensed individuals. Ideally, you'd want to hire a contractor who is familiar with treating museums, archives, libraries, when there's no other alternative. And we are just about wrapping up. Sherry has a couple of last notes here on creating a policy.
Okay, thank you. So it's very important to have a written IPM policy that is shared with your staff, your volunteers, your board of directors, because as the slide reads there, if it's not in writing, it doesn't exist. And one of the reasons for this is that educating your staff about IPM is very important. I mean, if you can just envision, let's say a volunteer or a staff member sees a bug or two and they smash it and they throw it away, well, you have no record of that, and you lose an opportunity there to nip something in the bud that could be dangerous. And there are some other reasons why you want your IPM policy to be written. It standardizes your procedures. It aids in your collections management decisions. It ensures consistency with your other policies in your organization. And if I haven't already said this, it really needs to be one of your core documents. And it establishes a foundation for communication with other departments in your institution, like facilities management and custodial service. So the people who are cleaning your building, the people who are making the cleaning schedules and deciding what's going to be cleaned and how that's going to be done. It's really important to communicate with those folks. And finally, an IPM policy that is written facilitates a swift and unified response to managing pests within your institution. So just kind of keep that in mind. I know some of you are from small organizations and you may be doing all of these things, but it really helps guide your process and lets you know that you're taking the right steps if it is written down. Okay, that's all I have.
Yes, great, thank you. So we are at the end of our webinar. We're going to say goodbye with our Martha Lisa there. I did want to give you guys our contact information, and we do have some minutes, so if you have any questions, this is more information for online resources for identification. And I'm sure there's many more out there. If you happen to know of any other good resources, if you just want to pop them into the comments box there, please do. I'll leave that up for a minute so you can copy it down if you want to check out any of these resources. As I mentioned, when you're putting together your DIY pest identification kit, it's really helpful to have sort of visual aids to help you along the way. These sites have either images of pests or ways to submit a photograph of your pest that you might have found in your collection. You can submit it online and then sort of get help from other people out there who might know more than you do about the pests. But here is Cherry and my information. If you have any questions, we'd be happy to talk about them now. Um, or if you want to email us later, that also works fine. All right, I'm not seeing
No
anybody
questions.
typing down there. Oh, Ryan is typing, but I will just let you guys know our next webinar will be coming up next month, of course. We will be doing a webinar on caring for photographic collections. We have a really excellent photograph conservator who will be talking to us about that. So if you wanted to sign up for that, that would be, you can do that through our website or through our mailings. Ryan just mentioned that she's having a problem with ladybugs. Any advice on that? I actually was just at a site up here that was having a problem with ladybugs, and they had installed a strip. I'm going to write it down in the comments there, a new then strip. This was something new to me that I haven't really gotten to investigate much closer. I just met with them a couple weeks ago, but that's something that's been on my list to look into was this product and dealing with ladybugs. So
Mhm.
maybe the both of us can look that up, Ryan. And I'll let you know. Sherry,
Yeah.
do you have any advice about
Yeah,
ladybugs?
they're all over Alabama in the fall, as Ryan probably knows. Another option that we didn't really talk about are light traps. They're not horribly expensive, and they can draw some of your insects to them. So that's an option for investigation.
Great, that's a great question. See, it looks like we have a couple other questions coming in. Oh, I'm not sure. It looks like Beth maybe doesn't have a question after all. Of course, if you do later, please feel free to send it to us. Thank you. Thank you guys for attending, and I hope
Thanks.
to see you guys next month. We're also working on the next round of in-person workshops, which will be in a location in Pensacola, and I'm working on another location in northern Mississippi, or excuse me, northern Alabama. I am looking to do a repeat of the risk assessment and essential policies workshop in Mississippi, hopefully soon. I'm working on getting it lined up at the Mississippi Museums Association conference. So keep your eyes peeled for more information on that. Otherwise, I will talk to you all soon and stay warm. Hopefully all the snow is melted. And I'll talk to you soon. Thanks, everyone.
Thanks. Happy holidays.